Group 17, halogen family. So in chemistry, we'll get majority of the salt producers as halogen. So it's basically our, I can say it as a salt producer. Salt producer. Which one? The halogen thing. Yes. So coming to the group 17, fluorine, then chlorine, bromine, iodine, and astatine, AT. I think this might not be familiar, correct? So first thing what I want to talk, just like I did in group 15 and 16. So first thing I'll go with the atomic radius. Atomic radius. So I will write in the order of that. Yes. So atomic radius increases down the group. So fluorine less than chlorine less than bromine. In the sense, astatine has got the highest atomic radius among everything. Second thing, ionization enthalpy. Ionization enthalpy. So write down the same thing. Okay. So fluorine, chlorine, bromine, iodine, astatine. Fluorine, chlorine, bromine, iodine, and astatine, and just put a greater than symbol. That's it. Electronegativity is also same. Electronegativity is also same. But I'll write down that also. Electronegativity. So that is also same. So again, write in same thing. Fluorine, chlorine, bromine, iodine, and astatine. Put a greater than symbol. So these two things are same. So like that we can compare and study. Electron gain enthalpy is also same, but there's a small difference. Electron gain enthalpy. Electron gain enthalpy. There's a small difference on that. Only thing is that I'd interchange chlorine and fluorine. The rest everything is same. Chlorine and fluorine I have to interchange. Rest bromine, iodine, astatine is same. I have to just interchange. Then put the greater than symbol. So like that, if we compare and study, it will be easy for us to remember. So has everyone copied down? Or you can take a screenshot and keep. Okay, anyway, I've taken a screenshot. So I'll be sharing with you later maybe. So coming to the next one, physical properties. Physical properties. So I'll write down the most important thing, leave about the astatine, but other than that, I'll write down everything. Fluorine, yes, chlorine, bromine, yeah, Br2, and iodine, I2. So fluorine and chlorine are what? Gases. gases. Bromine, liquid. And iodine, it's solid. Now coming to the color, fluorine, yellow color. Color is yellow. Okay, color is yellow. And coming to the chlorine, greenish yellow. Greenish yellow. Bromine, red color. Iodine is violet color. Coming to the color. Yes. And now next coming to the bond dissociation enthalpy. Bond dissociation enthalpy, the order. If I am writing XX, it means X stands for halogen. Okay, X stands for halogen. So I think electronegativity, electron gain enthalpy is there, right? Yes. So after that, so the order of this is what? Chlorine greater than bromine, fluorine, and iodine respectively. So the only thing we have to note down in this is, especially in fluorine here, correct? There is a large electron-electron repulsion. There is a large electron-to-electron repulsion among what? Lone pairs in fluorine molecule. Among lone pairs in fluorine molecule. This is something we have to note down. Next is the oxidizing power. Oxidizing power. So very important, these things. Fluorine is greater than, chlorine greater than, bromine greater than iodine. It is just same as our ionization enthalpy and electronegativity. If you want to remember oxidizing power, just relate it with what? Ionization enthalpy and electronegativity. It is same only. This is my iodine. Okay, this is my iodine. This. Oxidizing power is same as that of electronegativity and ionization enthalpy. Yeah. So has everyone taken screenshot of this and kept? Okay. And please note that whomever is attending the class online, that is send me the PDF once the session is over. Okay, the notes. So one of the question which normally currently since we got only MCQs and only for the PU board exam, yes, we got a theory thing. So one of the question which is mostly asked is what? Fluorine is a stronger oxidizing agent compared to chlorine. Why? Compared to chlorine. Why? So the answer for this is, so fluorine basically has got what? Low enthalpy of dissociation. Low enthalpy of dissociation. DISS is there. I just wrote only one S. Dissociation of the FF bond. That is my XX bond I told, right? Instead of XS, I'm just putting FF bond. Second one is high hydration enthalpy of fluorine. High hydration enthalpy of fluorine. The next thing is the oxidation state. Oxidation state and the chemical reactivity. So first, anyway, before going to chemical reactivity, I'll just say about the oxidation state. So I think everyone knows about electronic configuration well, correct? So first thing is all the halogen exhibit -1 oxidation state, exhibit -1 oxidation state or number, oxidation state or oxidation number -1, and except fluorine, okay, that is chlorine, bromine and iodine exhibit what? +1, +3, +5 and +7 oxidation state. I'll show it to you, don't worry, I'll show it to you. So for this, the understanding the oxygen state, okay, so I'll be drawing the hybridization and all of those things. So let me see if I can draw the hybridization. Even if I'm not drawing the hybridization, I will try to draw the energy levels, the NS, NP and ND is there, right? That will try to draw so that you will clearly understand. Okay, fine. Yeah. So I'm mainly going to deal about this thing, +1, +3, +5 and +7. So halogen atom in the ground state. So I'm talking other than fluorine. So halogen atom, or in the fresh page, I'll just write it down. Halogen atom in the ground state. That is other than fluorine, except fluorine. So Srikanth, I have not told anything. Yeah. So I didn't tell, I didn't speak anything. Yeah, don't rejoin. You can be in session only. I'm just trying to draw this thing. Yeah. I hope it's clear now. So NS, NP, and ND. Okay. So this I'm going to draw it for what? Which one? One unpaired electron. I'll write down here. Then only I think you will be able to understand much better. The first one, either it is for what? One unpaired electron for -1 or +1 oxidation state. Okay. So directly I'm going to do it. So I hope everyone knows electronic configuration. That's the reason I'm doing it fast. Next one, first excited state. This one is about my first excited state. So this is basically for what? 3 unpaired electrons, or I can tell you here +3 oxidation state. 3 unpaired electrons or +3 oxidation state. Yes. So I'm going to fill it. Next is my second excited state. Second excited state. This is for my +5 oxygen state. +5. Last one is my +7. So has everyone taken a screenshot of this? Yeah. So next, let us see the chemical reactivity. So first one I will say about reactions with water. So Prithvi, last one is the third excited state. Okay. Second excited, and this is my third excited state. Yeah. Yeah. Anyway, we'll come back to this later. So reactions with water. So very important one. Okay. Very easy also for us. So first I'll take what? Fluorine. Fluorine plus water. Yes, this is giving me 4H plus. So if I want to balance it, I'll just put 2 here and 2H2O. So 4H plus, not H2. Yeah, 4H plus 4F minus plus oxygen. So what we can infer from this, fluorine oxidizes water to oxygen. Fluorine oxidizes water to oxygen. So this is the inference from this. Second one, I'll take a more general thing. X2 plus water is giving me HX and HOX. So this is mainly for where X is equal to what? Chlorine or bromine. So chlorine and bromine react with water to form what? The corresponding hydrohalic or hypohalous acid. Like HCl we'll be getting, right? And HOCl. I'll write down in words chlorine and bromine. Correct? Reacts with water to form hydrohalic and hypohalous acid and hypohalous acids. So we have discussed about fluorine, chlorine, bromine. The last one is what? Iodine. Okay, so iodine. So it is different from all of the other things. So I'll use a different color for that. So 4I minus plus 4H plus O2 will give me what? 2I2 and water. In the sense, I'll write down in words. So iodine can be oxidized by what is H plus? It is an acidic medium. For example, iodine is this thing, correct? I minus, this is my I minus, okay? I minus can be oxidized by oxygen in acidic medium to get iodine and water. So if I write it on words, I'll simply write on what? I minus, I'll type it down, that is much more better, I think so. I minus, this is superscript, okay? Can be oxidized by oxygen, by O2, by oxygen in acidic medium. H plus is my acidic medium to get what? Iodine and water. So just like the group 16, I'm going to teach now hydrogen halides. Hydrogen halides. So if you don't know what it is, HF, HCl, HBr, HI, hydrogen and the corresponding halide. So yeah, am I audible? Yeah, I think so. Yeah, fine. Dipole moment, I'll write down some few things. Thermal stability. So this will help you to compare and study well. Dipole moment and thermal stability. Then I'll write down bond dissociation enthalpy. Bond dissociation enthalpy. So for all of these things, you have to only remember one single thing. Okay. That is HF greater than HCl greater than HBr greater than HI. For all of these things, you have to remember only this order. Dipole moment, thermal stability, bond dissociation enthalpy. And now coming to the acidic strength. Acidic strength, and let me take reducing power and bond length. I'll write down everything. Acidic power, acidic strength, reducing power, and bond length. So again, write down all of these things. HF, HCl, HBr, and HI. Just change the signs. Just change the signs. Put less than. That's it. So I hope it's easy for everyone to study like this. So hydrogen halide properties. If you study like this, it's very easy. Dipole moment, thermal stability, bond dissociation enthalpy has got same order. Acidic strength, reducing power, bond length. So all of these things they can ask in the entrance as well as in the MCQs. Inorganic chemistry, P block is the most important chapter.